to download a data set and an R markdown file and some other things. So there are instructions at that link that I put in the chat. Just so that I know if everybody has that, could you give me a thumbs up if you've been able to download what we need for today? So that'll give me an idea of whether I need to speak slowly at the beginning or to wait for people, or if I can move along. So if you have that materials downloaded, if you could give me a thumbs up, great. Cool, great. So if you don't have that downloaded yet, you'll need to click on the code. Let me share my screen. Yeah, there's a few more. So this is what the website will look like, and you'll need to click on this code button and download the zip file, and that will include all the materials for today. If you're on a Mac, it'll unzip itself, and you just need to put that folder somewhere. If you're on a PC, you might have to unzip it with something, some program. All right. Cool. So I have about half of the people, I think, that gave me thumbs up so far. And I'm just going to flip over to my slides because you won't need the files just yet. And then we can get started. So today I'm going to talk about the ggplot2 package in R, which is used for graphs, making graphs and data visualizations. I find this to be one of the best parts of R. You know, lots of other statistical software can do the same kinds of things that R can do, but I think that the data visualization tools, and ggplot in particular, in R really make it stand out. And so I'm really excited to provide you with all the kind of tips and tricks I've learned in ggplot2 over the last few years. While we go through the tutorial, please feel free to put any questions you have in the chat. I will try and keep an eye on it. But if I miss your question, also feel free to unmute yourself and ask it out loud. And that way we can make sure everybody's on the same page. Okay, so we're going to create some basic figures in R. We'll do bar graphs, we'll do box plots, histograms, and then some cool kind of new data visualization called a rain cloud plot, which is really great if you have a continuous variable and a categorical variable and you kind of want to look at them together. Like, you know, if you had age and look at the distribution of age across the categories of marital status, you could use a rain cloud plot. So we'll do that towards the end. How to follow along and participate. So you'll need those files from the GitHub repository. And then what you'll just want to do is open RStudio. And then if you followed along in the instructions, you might have already done this already, but you'll need 3 packages for today. So you'll need the tidyverse package, which is the main package where ggplot2 lives. You'll need the gghalves package, which is an additional method for an additional option for making some cool graphs. And then you'll need Haven, which is going to be the package we use to open the data that we have for the workshop today. So if you've already opened RStudio, you can go ahead and install those 3 packages by going to the Tools menu and choosing Install Packages and then typing the names of those 3 packages. And so I can put them in the chat. That might make it faster for some people to get them installed. Tidyverse, gghalves, and Haven. So yeah, so if you go to Tools, Install Packages, you can just copy and paste what I put in the chat and then hit Install, and it'll install them for you. Then, once you have those installed, you're going to want to open the project file that we have for today. So there are a bunch of different ways to do that. You can just double click on it. Yeah, I will share the slides after the meetup. I'll have to put them on GitHub because they're in HTML. So yeah, so I will share the slides. You'll see that in the file, the slides contain everything that's in the file, so you'll be able to follow along with the code in the file as well. So the next thing you'll want to do is open the project file. So let me share my screen and show one way to do that for those of you who don't use RStudio all that much. So if you've opened up RStudio and maybe you've gone to Tools, Install Packages, and you've installed your packages here, that's not the right thing, with Tidyverse, gghalves, and Haven. If you've already done that, then you can open the files for today by going down here to the lower right corner, clicking on Files. This is all stuff that's on my computer, so yours will look different. And then clicking these three little dots, and this will let you navigate to wherever you save the materials for today. So I saved mine on my desktop, which is bad practice, but I wanted it to be easy for me to find when I was working with all of you. So I saved it on the desktop, so I can click on that folder to open it. And these are now, this now shows all the files in the folder that that you should have downloaded for our workshop today. The one you want to open or want to click on is the R project file. This is a file that sort of holds everything in the folder together so that you don't have to use file paths to find your data. So if you click on that to open it, and it shouldn't really look that much different once it's open, but now you're in the project. So now you can go ahead and open the R Markdown file, which is the one we're going to be working in today. So you can just click on that. So I'm going to stop here for a second and just let everybody hopefully catch up to this point, because this is the file we'll be working in all day, and I want to make sure everybody has it and is able to see it. So if you get to this point where you have the R Markdown file open and it looks something like this in the upper left corner of your RStudio, once you get there, if you could give me a thumbs up, either on your screen or in the chat. Great, perfect. Great. Yes, awesome. If you got to this file in a different way from what I showed, that's fine too. There's lots of ways to get here. For those of you who are just joining us, here's the GitHub repository where the files are for today and some instructions for downloading them. Okay, so let's go ahead and just get started. For those of you who are still working on downloading, once you get those files downloaded, you'll just need to open the R Markdown file, which is where we're going to be working all day today. I'll go through just a few things on RStudio, and then I'll flip back to the slides and we'll start actually creating some graphs. So I wanted to go through what you're seeing here in this project file. The first thing, the Pew Research Center, that is the code book for the data that we're working on today. That is a Word document. So if you want to know what's in the data that we have, you can open that. You have a data set right below that right here. Let's see if I can widen my screen a little bit so you can see the names of things. This is the data set. The fourth thing here is the R Markdown file that we're going to be working in today. The fifth thing is the project that holds us all together in one folder, so you don't have to worry about file paths. And then the README is just the instructions that you saw on GitHub for how to download everything. So that's what's in the materials for today, in case you need any of them. We will be working entirely in this R Markdown file, so I'm going to kind of maximize my screen. You might want to also do that. If you haven't worked in an R Markdown file before, what's really nice about it is that you can type just plain old text outside in kind of the white background area. And then in these gray spaces, those are called code chunks. That's where you type the code that you can run in R. And those code chunks, they start with 3 backticks, they end with 3 backticks, and then they have a little option at the top where you put the language you're using, which is R. I think you can also do Python in here. And then you can name your chunk. And so when I refer to chunks as we're going through this today, this is what I'm referring to. So when I say chunk 1, this is chunk 1. When I say chunk 2, this is chunk 2. So if I say run chunk 1, that's run this code right here. To run the code, there are a few different ways. If you want to run everything in your code chunk, you're just going to hit this little green arrow. So those of you who are in this file, we can go ahead and do that now. Hit the little green arrow, and that's going to run all the code in that code chunk. You can also run just one line at a time by highlighting it and going to run up here, or using a keyboard shortcut like you normally would in R. So go ahead if you haven't already and run that code chunk. One last thing I want to tell you about R Markdown, for those of you who are new to this file type, is you can type notes in here if you want to keep some notes to for yourself. You would type them either outside of the code chunk just by, typing regularly as you would in a Word document. Or if you want to type them in the code, like maybe you want to leave yourself a message about what this code actually does, you'll need to add them as like comments or annotation that you would. So you would hit a hashtag, and then this code opens the packages. So outside of the code chunk, you can type just regular text. Inside of the code chunk, you want to start the line. If you're typing a note to yourself, start each line with a hashtag so that R doesn't think you're trying to type code. It knows it's just a note, an annotation. So that's all I'm going to do to kind of walk you through what you're seeing here in R Studio. Actually, I'm going to do one more thing. Let's go down to code chunk 2, where we're going to open the data. And I just want to make sure everybody gets the data opened before we start making some graphs. So code chunk 2, and the name is here, is going to open the data using the read SPSS function, which is from that Haven package. And these data are downloaded directly from the Pew Research Center website. So I haven't changed this file at all. I haven't changed the name of the file. I haven't changed what's in it. This is directly downloaded from the website, and then we're going to open it up. So we open that up by hitting the arrow, and it's going to work for 30 seconds, maybe, depending on your internet connection. And then you should see some data up here in the top right corner. I named the data Global Data 2019. And so that's what you should see up here in your top right corner. All right, so I'm going to now go back to my slides. And we're going to walk through creating some graphs. And you have all the code you need to create all these graphs in that R Markdown file. And so we're just going to walk through all this code today. So we are, like I said, using the Global Attitudes and Trends data set from the Pew Internet and American Life website. This particular data set goes beyond American Life. It's got global life. If you need the data set or if you want to look at other data from Pew, here's the website you can go to, and I will post these slides after this session. I'll post them at that GitHub page, so you can just go back there where you got all the materials. We just did this part. So if you ran code chunk 2, you've already imported your data into R. And so this slide is just telling you basically how to do that. The next thing we're going to do is data cleaning. Since I could spend this entire day talking about cleaning up these data, but since we want to get to some graphs, I'm just going to say go ahead and run code chunk 3, which uses the tidyverse to clean the data set. And if you're interested in more information about that, we do data cleaning meetups all the time at Arlidiz St. Louis. I'm sure there will be one coming up. But go ahead and run that code chunk 3 to clean up the data. And what you're going to see then once you clean up that data is in the top right corner, underneath the whole big data set that you just brought in, you'll see a smaller data set because this data cleaning has restricted the data now to 4 countries, where the original data set was something like 25 or 30 countries. And we've restricted it to these 4 countries so we can look at the data a little closer for Israel, Lebanon, Tunisia, and Ukraine. It also restricted it to a set of variables, I think 7 variables, which is the country people are in, their sex, their age, whether they think life is better for males or females or equal in their country, how satisfied they are with their country, how satisfied they are with the economic situation in their country, and whether their life is good from 0 to 10, where 0 is terrible and 10 is excellent. So those are the 7 variables we're going to use. And those are all explained in the code book if you want more information about them. Great. So that is the data cleaning. And if you've run chunk 3, you should be all ready to go. And then chunk 4, just to make sure we're all on the same page, if you run chunk 4, you should see some output like this on your screen. So it shows the 4 countries we chose: Israel, Lebanon, Tunisia, and Ukraine. The sex variable, male and female. The age variable, you can see that it's continuous. Better gender, do men have it better? Do women have it better in your country? Are they same, both equal? Satisfaction with your country is measured by just 2 choices: satisfied or dissatisfied. Your economic situation in your country is very good, somewhat bad, very bad. And then this life ladder goes from 0 to 10. How good is your life? Basically, terrible to great. So hopefully you got something like that when you ran code chunk 4. So what we're going to do next is use the ggplot2 package for plotting. This is in the tidyverse. So if you've loaded tidyverse, you have the ggplot2 package. You can just load it by itself too if you'd like. GG in ggplot stands for Grammar of Graphics. And the plots in ggplot2 are built in layers, and you're going to see that really clearly as we go through some of the plots today. So one of the great things about this is that you can continue to add on layers that can format your plot in ways where you can really communicate your data clearly and format it so that you can get your point across really well, just by adding on additional layers. So let's get started. Let's look at some examples. We'll start with a bar chart. So this is in code chunk 10. I'm not sure why I skipped code chunks 5 through 9 when I created this, but we're down at code chunk 10. And you'll see the name of the data. So this is the clean data set. And so that's, this is just a little bit of a snapshot of what that data set looks like. And then what's going to happen is you're going to send that data through this, this character here, which is called a pipe. And this is in the tidyverse that you use the pipe. And that this pipe acts like a pipe in your home, wherever you live or wherever you work, like a pipe that might bring water from one place to another. So we're sending the data through this pipe like you'd send water through a pipe. We're sending it through a pipe into the ggplot function. So this is the grammar of graphics plot function. And within that function, we have to tell R what we want in our graph. What do you want on the x-axis? What do you want on the y-axis? What do you want for color? All those things happen in this part of the function, which is the aesthetics. AES stands for aesthetics. And this particular plot we're starting out with is going to be very simple. I'm only going to specify the x-axis, so that's that horizontal axis. I'm going to put the sex variable on that axis. So what you've seen now is the basic first layer of this plot. So ggplot has created this, place where the graph is going to be, and it's put the sex variable on the x-axis. Then you have to start adding on layers to give R more information about what you want next. So the next thing I did was add on a layer, which is the geometry layer. What geometry do I want? Do I want a scatter plot? Do I want a box plot? Do I want a bar plot? What do I want? In this case, I want a bar plot. So geom bar is the geometry is a bar plot. And here you get your very first, if you run code chunk 10, you get your very first basic bar chart. No frills, default everything, not making any changes, but it's pretty nice for just a tiny bit of code. So you have the sex variable on the x-axis. You have it automatically gives you the frequency or the count on the y-axis without you even having to say anything. And it's got this kind of standard formatting that you see in R graphs. That was code chunk 10. If you haven't already run it, you probably want to run it now. And we're going to move along. And we're going to make a fancy bar chart. So we're going to start with the data set. Again, global data 2019 clean. We're going to pipe it into ggplot just like we did before. And then we're going to add on the geom bar, but this time I'm going to fill it with a color. So I chose deep pink, but you can choose any color that you want. So if you want a different color here, I feel free to change that. You could type in the word blue or green or red or orange, whatever you like. And there, if you want a full list of all the colors that are available in ggplot, you can just Google ggplot colors and you'll find a whole big list of colors. But there's more. I don't just want to make the same boring plot, but now it's bright pink. I also want to add some good labels because, a graph without good labels is hard for people to understand. So I do that by adding on another layer. It's the labs layer or the labs layer. The label I want on the x-axis is sex. The label I want on the y-axis here is frequency. And then I want to give it a title. And the title should have, if you're making something to put in a report or a manuscript, your title should always have the sample size, the year the data were collected, and then sort of the content of the chart. So this is my sample size, 4,058. You can check that in your Up in your environment on the upper right, it'll say 4,058 observations. So it's a sex of 4,058 participants in a 2019 survey of people. So this gives people a lot of good information about the graph. And then the last thing I want to do is this, to me, this gray in the background is just a lot of extra heavy color that I don't really need or want. And so what I like to do is use a theme. And my favorite one is theme minimal. And so I add on, you can't see the plus here, but you can see it maybe in your R Markdown file. So I add on another layer, which is theme minimal. So that got rid of the gray background. So there it is with the gray background. There it is with the theme. There are a whole bunch of different themes, and I'll click back over to RStudio in a little bit and show you how you can find where all those themes are and what they're called. All right. Are there any questions? Yes, I did get a question in the chat. You can also put the color codes in there. Let's see. There's a great website for finding color codes, Color Brewer 2, I think. Yeah. This website, Color Brewer 2, I'll put in the chat. This gives you a lot of great, this gives you great ideas for color. These are the codes that are being asked about in the chat. So like if I wanted this green, I could take this code here and put it in where I have the word deep pink here. So then you'd have that green color in there instead. So Color Brewer 2 is great too, because you can find colorblind safe colors. So it'll give you colorblind safe. If you're going to print a report, you can do print friendly colors. You can ask for 5 different colors that are on the same kind of a palette. So there's lots of cool stuff you can get from this website. Cool, good question. Okay, so that is chunk 11. If you haven't already run it, go ahead and run chunk 11. And you can see this graph. If you'd like to fill it with a different color, please go ahead and play around with replacing deep pink with something from the Color Brewer or just the name of a color that you like. When I was a little kid, I wanted every single thing to be magenta, which my grandfather was very confused by because he didn't know what that was. So that's a color I use sometimes in my graphs, even though it's very, very bright. So yeah. All right, so let's keep going. Let's do a fancy bar chart with color for each category. So sometimes when you have a categorical variable, you want each category to be a different color. So maybe in this case, I want males, the bar for males to be blue and the bar for females to be green or something like that. So you can do that with either adding your own colors, or you can do it with one of the color palettes that are created for you by in our studio. So or in R. So we're gonna start with our data, pipe it into ggplot. And we've got a little bit of a change here. In the aesthetics, we have the sex variable on the x-axis, but we also want to fill it. We want to fill those bars based on the categories of the sex variable. So we're going to do fill equals sex. So that'll make each category of this sex variable a different color. It'll be filled with a different color. So we changed that layer a little bit. Add on geom bar. So already you get 2 different colors, this kind of salmon orangey color for males and this kind of teal swimming pool color for females. So great. So and it also gives you automatically the legend over here telling you which color belongs to which. which in this case is sort of redundant because there's only 2 categories. You already know this is male and this is female, so you don't really need that legend in this case. Sometimes you will, sometimes you won't. Add my labels. Here's where you can change colors and you don't have to pick every single color for yourself. So here it's only 2. I might be fine just putting red and green or blue and yellow or whatever. But if you had like 6 categories and you didn't want to spend a bunch of time trying to find 6 great colors that go together, you can use what's called a palette. And this palette is called Set 1. So I will show you as soon as I finish with this code, I'll go over into RStudio and show you where you can find the names of all these palettes so that you can try some other ones. So this layer, Scale Fill Brewer, is changing the fill, which it's filled by sex up here. So this is changing the fill so that's using this palette of colors to represent the different categories. Then I added on my theme, but because my eyes are old, I need bigger font. And you might have people that you're working with and you want to give them a little bigger font. So one way to do that is in my theme, in my theme layer, I add this option base_size. And then I think the default size is 11. So anything larger than 11 is going to make all the font, all the text in your graph bigger. It's not going to make it all the same size. It's going to keep the relative differences, like this is larger text than this along the side, a larger text than this over here, but everything gets a little bigger. So I'm going to go back a layer. So see how all the fonts are pretty small. Then when I make them, they all get slightly bigger. And so you can play around with a number in here. Anything above 11 is going to make everything bigger. Anything below 11 is going to make everything kind of smaller. 11, I think, is the default number. Okay, so I'm going to take just a quick detour back into my RStudio and show you where to get those palettes. So I changed this to magenta so you can see how terrible, terribly bright that is. These palettes are over here in the bottom right corner. If you click on the help document and you start to, and you type scale, fill, brewer, that layer that we used, then you can scroll down a ways until you get to this section called palettes, and it gives you all these different palettes that you can play around with. So maybe I think this is red and gray. So if I copy that and I change this set 1 to red gray, or I don't know what that's going to be, but I'll run it. Yeah, that makes the second bar pretty hard to read, so that's probably not good. Maybe I love this dark 2. That's one of my favorites. So I could put that in there and run it. And then I get this green and orange colors. So there's this whole list of palettes. If you go online, you can look it up and it'll actually show you the palettes and what colors are in them and how they're sequenced. But here's just the names of them. And again, that was under help. If you put that scale fill brewer in there, it gives you all the palettes that you can choose from. Cool. So let's go back to the slides. I think we've got one more bar chart here. Super fancy bar chart. Taking the data, typing it into ggplot. I've got the sex variable on the x-axis and also the fill on the for the sex variable. I add on my bar. I add on my labels. I add on my palette, set 1. I add on my base size, getting a little larger. And one new thing I added on here was base family. So if you go back, you can see that this is all this kind of sans serif. It looks kind of like Arial, but I'm not sure if that's what it is. It's a font without the little extra at the end of each letter. If you want a different font, you can do that in the theme under this base family. There are a few that everybody has, which are serif, sans, mono. I think there's one more. Those are the ones that everybody has. And then depending on your operating system and the fonts that you have installed on your computer, you can also put in like Times New Roman or Arial or Helvetica or whatever fonts you have installed. It's not going to be the same for everybody. So, you know, you're safe using serif, sans, and mono. If you're working with somebody else who has a different computer, maybe is at a different company, you're probably safe with some of the very basic fonts that everybody uses, like Times New Roman. But if you have one that you like that's a little fancy, then I wouldn't recommend unless you've tested it with other people. So that's how you can change the font. So if you want to go back and look, that's the font, that's the default font. If you go add the serif, you get a little different font there. And then the last thing I'm going to add here is we talked a minute ago about how this is redundant because males are red, females are blue. Clearly male, that's the red bar, female, it's a blue bar. So I want to get rid of this, give more room to my actual chart. So if I add another theme layer and I say the position of the legend is none, I do not want a legend here. And so that's one way I can get rid of the legend. So now you have a very clean, nice looking graph that you could easily just put right into a report or a manuscript. You know, the font size looks good, the title looks good, everything looks good. So go ahead and take a minute and fill in the code in code chunk 14 based on the instructions under the you try it. So you're going to change a variable. Oops. You're going to change a variable. You're going to change the theme. Did I tell you where that was? The theme? I don't think I did. So let me go tell you how to change the theme. Go over to RStudio. So to change the theme, you're going to come back here into the help document again and just type the word theme. Start typing it. You should get this whole list of all these themes. So where I have theme minimal, you can put theme classic or theme dark or theme gray. Try one of these other themes and see what it looks like, or try a few of them and see how they look. And why don't we take about 5 or 6 minutes and you can give it a try. If you have any questions while you're working or anything else, go ahead and put it in the chat and I will try and help you out. Okay, great. So hopefully you've had a chance to try some things. Does anybody have a theme that they like so far, or a color palette? Well, let's go through one example. Okay, yes, we will remove the NAs. So I'll show you a couple different ways to do that. So I'll go through one example here of what you might do it. So, so there's the data set piped into ggplot. You're going to put better gender on both the x-axis and for the fill. Geom bar. So this plot does have NA in it. So We had a couple of requests to show you how to deal with those, and I'll show you two different ways. One is by dropping NA from the variable, and the other way is by giving it a color within the palette. Adding on the labels like we have been doing. Choosing a palette. This time I chose the paired palette. I kind of like the colors in this palette. I chose to change my base size to 16, which maybe doesn't look super great because the labels down on the bottom are kind of squished together. So we might have to do something about that. I moved the legend out. Well, that helped with the labels, but now we have this NA that doesn't have any color. And so that's annoying. So here I show a different palette and a different font. So I've got the set one palette now and the mono font, which kind of makes it look like an old-fashioned typewriter. And here's how you might change the color for your NA bar. So you have to add in, when you use a palette, it doesn't give a color for NA. So you have to choose your own color. You could go to that color brewer website and choose a color that you like, or you can just choose the name of some random color that you like. I chose orange in this case. So that's one way to deal with the NA values. If you just do not want NA in your graph, if they're not interesting or useful to what you're trying to communicate, you can also drop them. And let me go over to my RStudio and show you how to do that. There will be some slides on that, but since we have some interest, we can do that now. That would go up here kind of before the ggplot, and you would just make you're piping that data in. You pipe it into a function called drop NA. And then you put the name of the variable you want to drop the NA for in here. It can be one variable, it can be multiple variables. We're only working with one right now. So drop NA for better gender, and then you have to add another pipe on to that. So you're piping in this data with those observations dropped. So then when you run this, it's going to give you a graph without the NAs. And one other thing while I'm here, I can show you is notice how my title is cut off after fro. It's too long for the space that I have. So I needed to go down to a new line. I need to add a line break in there. To do that, I would add a /n for new line, wherever I want that line break to be. Right in that text. So it'll feel weird, like it's going to print that /n, but it doesn't. So if you run that now, you get a line break right where it is. Yeah, /n. So you can put that in wherever you want the line breaks to be. So there we go. Now you can see the entire title of my graph. I put line breaks in where I needed them. Okay, cool. So that was a little bit of extra stuff from the slides, but let's, before we move away from, so we're going to now start moving into some more complex graphs that have more than one variable. Are there any remaining questions on this single variable bar chart? Actually, I think we're going to do maybe a little more with it. We're going to show how to convert that frequency to a percent on the y-axis. Any final questions before we move on? Okay, cool. How to reduce the font size? That is in that base size right here. Just make that a smaller number. So 11, I think, is the default. You know, if you want it even smaller than that, you can put like 9. It makes it tiny. If you want it humongous, you could put 50, whatever you want to do. All right, cool. Other questions? All right, great. So please feel free to put them in the chat if you have them. I'm going to go back to my slides. All right, so now we're going to have two variables in our graph. We've been working with just a single variable. So we did the sex variable first, then we did the better gender variable. Now we're going to have two variables at once. So we're going to take that data, we're going to pipe it in, dropping the NA values like we just looked at for the better gender variable, pipe that into ggplot. And now we're going to look at better gender variable on the x-axis, and we're going to fill it with the sex variable. So we're now looking at how males and females answer differently about who has it better in your country, men or women, or same, they both have the same kind of lives in your country. So x-axis is better gender, the color is going to represent sex. Add on the geom bar. So now we get a completely different look, right? So we have stacked bars now where males are this orangey color, females are this blue color. And now we need this legend. In the graphs we were just working on, we didn't need the legend because it was redundant with the x-axis, but now we need it. So we've got better gender across the x-axis, we've got sex as the fill. Labels, like we've been doing, and then scale, fill, brewer, like we've been doing. I chose the paired palette. This gives nice, like it'll give dark and light blue, and then dark and light green, and then dark and light orange. So it gives you, like if you have data where there's two categories, it's kind of nice because it gives you two versions of the same color. Add the theme, base size 12, base family is that mono font that looks like a typewriter. And that's it. So now you have a nice little stacked bar graph. The one problem with doing the stacked is that it's really hard to tell the relative difference between the sizes of the two colors. Like, is this blue color, how much bigger is this than this dark blue down here? So it's kind of like a pie graph in that way, where you cannot, it's hard to tell the relative sizes of the pieces of pie. And so for that reason, a lot of people choose to do a different kind of data visualization. So we'll look at another option for when you have two categorical variables and you want to see how they relate to each other. We'll do a grouped bar plot, which is, more recommended for this kind of data. So take that data set, pipe it into drop NA, pipe it into ggplot, better gender on the x-axis, filled by the sex variable, add on geom bar, and here's the option that makes it side by side, position equals dodge. That's what makes it side by side instead of stacked on top of each other. So now you have on the x-axis, who has it better in your country, men, women, or same, both equally. And then you have who answered the question, a male or a female. So males think men have it better less often than females do. Males think women have it better more often than females do, and so on and so forth. So now you can get a little more information from that graph. Adding on the labels. In this version, it was hard to know what is meant here by sex. Is that the sex of the respondent, or is that the sex of who you're answering the question about? So you might want to change that label. So we're adding to our labels now. We have the label for the x-axis, we have the label for the y-axis, we have the title for the entire plot, and then we have the label for the fill. So since fill is by sex, the label here is going to say survey participant sex as the label for fill. So that gives people a little more information about what that variable is. Add on that paired palette. Use a theme with a base size of 12 and the serif font. All right. So, yeah. Yes, Vishnu, you can export the image separately, and when I go back to our studio next, I will show you how to do that. Yep. All right. Cool. So, go ahead and give those new options a try. Put country satisfaction on the x-axis and sex as your fill color. Drop the NA values, add good labels, use a palette, and fix the legend title. So let's do like 4 or 5 minutes. So we'll come back at, I know it might, you all are a half hour different than my time. So just 5 minutes, we'll take 5 minutes. And you're working in code chunk 16B. Okay, I think it's been about 5 minutes, maybe 4.8 minutes. I don't know. So let's keep going. We've got some other kinds of graphs to do. Let's look at one possible you try it answer. So you could have done a lot of things here, and yours may look very different from mine. This is in chunk 17. So if you're not getting your code to work in chunk 16B, you can look at chunk 17 and see if you can figure out where you're going wrong. It's probably something like something's misspelled, which is what usually happens to me, or you know, I spelled theme without the E on the end, something like that. So here's chunk 17, taking the data, piping it into the drop NA function to get rid of the NA values for that country satisfaction variable, piping that into ggplot. Country satisfaction on the x-axis fill is sex, add on geom bar, position equals Dodge. So we are getting, you know, 2 bars, one for male, one for female, for the satisfied and dissatisfied with my country. Boy, it looks like a lot of people are dissatisfied with their countries in this particular data set, which I guess is not too surprising, but it's too bad. Labels, we have the x-axis, satisfied or dissatisfied with your country. The y-axis is a frequency. The title at the top, the participant sex is the fill. Scale Phil Brewer with a nice paired palette, so you get 2 different shades of blue. Theme minimal is my favorite theme. A lot of people like theme classic, if you haven't tried that one yet, or theme BW for black and white, which is really useful for journals that won't accept color. So that's one option. Maybe you did a bigger font or a different font or something like that, but there's one way to do it. So, you know, as you're starting to gather, if you haven't used a lot of ggplot before, there are millions and millions of things you can do in ggplot. We barely scratched the surface, and we already have, like, you know, 10 lines of code here for a bar graph. So we're going to keep learning a few more of these, a million rules for ggplot. But before we go on to different kinds of plots, we're going to look at how to use percentages. So back here, it was good to see the satisfied and dissatisfied, but maybe you're more interested in among everybody who's satisfied, what percentage of those people are male versus female? Among everybody who's dissatisfied, what percentage are male versus female? Maybe the frequencies are different in different groups, and so you want to look at percentages instead. So we're going to go ahead and do that now. Get some percents to put on those y-axes. So we'll take that data set, and this is going to require us to do a little bit of data management before we pipe it into ggplot. And if you haven't been watching the slides as we go, now might be a good time to watch the slides, because I think walking through it step by step here, it'll maybe help it click a little faster. So take that data set, pipe it in to a function called group by, and this is going to group the data by whatever you put in the parentheses. So it's going to group it by country satisfaction and sex. So you're going to get dissatisfied, dissatisfied for males and females, and satisfied for males and females, and then NA for males and females. That's what that function's doing. And then we're going to pipe it into a function called count. And that function gives you this N value here. So satisfied for males and females. So in the data set, satisfied males, there's 447 of them. Satisfied females, there's 499. Dissatisfied males, 1353. Dissatisfied females, 1618. NA values, there's 52 males and 89 females who have missing values. So you can use this information now to get percentages. So out of everyone who's satisfied, it looks like it's about half males and half females, a little higher percentages females than males. To get that percentage, you want to group it by, and this is important, you might want to type this in your R Markdown file somewhere. You want to group it by whichever variable you want to add up to 100%. So do I want out of 100% of the people who are satisfied, what percentage are males and females, or do I want out of 100% of males, which are who is satisfied and dissatisfied? You want to pick the variable that you want to add up to 100% in your graph. In this case, I want country satisfaction to add up to 100%. So I want to know out of everyone who's satisfied, what percentage are males and what percentage are females. Pipe that in to a function from the tidyverse called mutate. And this is the function you use to make new variables. And I'm making a new variable called perc, short for percentage. And this variable is taking the N value from the N column and dividing it by the sum of the N values in this group that you just grouped by. And then multiplying that by 100 to get a percentage instead of a decimal. And so then you see that here. So out of everybody who's satisfied, 47.3% are males, 52.7% are females. If you add those two numbers up, you get 100%. So out of the 100% of people who are satisfied, a little under half are male, a little over half are female. Out of everyone who's dissatisfied, 45.5% are male, 54.5% are female, and then you've got the missing values. So that's how you create the percentage that you can then pipe into your ggplot. I think that's what we'll do next. So any questions on that? I know that that's a lot of data management, and if you haven't used tidyverse before, it's going to just look like, a whole new language. I would save this little chunk, put notes next to it or something, because it took me forever to remember how to do this. I always had to go back and grab old code to remember. Okay, let's put it into a plot. We'll see if I got any questions. What happens if you don't use group by? Then it's just going to give you the percent of each person in the data set, which is not going to be useful for you. So it'll make the whole data set add up to 100. Yeah. Ungroup works. I don't have that in my slides. I don't use ungroup all that often, but if you group things like we did here, and then you wanted to go back to the full long data set, you could use ungroup, I think, to go back to the full data set. Right now, what we have is this new tiny little data set that's just summary data. I would have to test that, though. I really don't use ungroup that often. And we can do that at the end, Vishnu, and take a look and see what it does. Cool. You could always add it on. You could pipe it on at the end here and see what happens in your code. In chunk 19, you could send that last line through a pipe to ungroup, see what happens. All right, so we're going to take that data, pipe it into group by, pipe it into count, pipe it into group by again, pipe it into mutate to get that percentage. And then after 5 lines of code, we can finally pipe it in, just to drop NA, after 6 lines of code, we can pipe it into ggplot. So now we have a lot of stuff going on in this layer. We have aesthetics, we have country satisfaction on the x-axis. Oops. We have that y, that percentage variable, y equals perk, or that percentage variable that we just created 2 lines above using that mutate function. And then we're going to fill it by sex. So we've got our basic layer there. Add on, we're using something new, geom_call. Call is for column. It's a bar graph, but it's when you have summary data. When you already have the percentages or the frequencies or something that you want to plot, you don't just have individual observations. So we, a couple lines above here, back here, we created those percentages, and we just wanted to plot those percents. We don't want it to plot each person. So that's why we're using geom_call. When you have summary data, use geom_call instead of geom_bar. Position equals dodge, just like we've been doing. Labels go here, just like we've been doing. Scale fill brewer, same thing we've done. Theme minimal. And that's it. There you have now. Looks a lot different from the graph that we had a few slides ago. So now the satisfied bars, these add up to 100%. So out of everyone who's satisfied with their country, a little bit fewer males than females. Out of everyone who's dissatisfied with their country, there are quite a fewer males than females. Okay, cool. So, that's the end of the bar plot section. That was quite a bit of bar plotting, but I think those are pretty widely used in a lot of research, a lot of categorical variables out there. So we're gonna, before we move on to histograms, are there any remaining questions about bar plots? Okay, hearing none, we'll move on. Histograms. Okay, so when you have a continuous variable and you want to look at its distribution, maybe you're trying to meet an assumption for a statistical model, or I mean, that's probably the main reason we use histograms. We might also just be wanting to show people what the distribution of something looks like. Usually for that, you'd use a histogram. And you could also use a density plot, but that kind of masks some of the important features. So histogram's probably better there. So we're going to start with the same exact way we've been starting. Take the data set, pipe it into ggplot. In the aesthetics, we're going to use age, right? We're now looking at a continuous variable. So age is sort of continuous because it's in years. So it goes, from 18 to 80 something, I think, in this data set. We're going to age on the x-axis, and you can see that ggplot's already put its main first layer down for you. We're going to add on the geometry is a histogram. And here's where you get to see a little flaw in the code for the software that I use to make the slides. So this is an R package that I use called Flare. And usually it gets rid of any errors, but for histograms, it leaves this little message up at the top. So you'll have to just ignore that. So that's your basic histogram. So it looks like age in this particular data set is right skewed, so it's not normally distributed. So, if you've got a model that needs a normally distributed variable, this is probably not going to work out. You'll need to transform it or do something. So let's make that fancy, just like we've been making everything fancy. Take the data, type it into ggplot. Now we've got age on the x-axis, and we're going to fill it by sex. So maybe if we want to see if the age distribution in these 4 countries is different for males and females. Are there more young males and fewer older ones, or what? Is there any difference at all? We're going to add on the geometry, which is a histogram. And I'm using the color white here, not to fill it, Notice I've used fill in most places so far, filling it by sex. So male is the orange color, female is the teal color. It's filling it by sex. I'm using color to make kind of the outlines of the bars here, the little bins for the histogram, so you can see them a little better. When we were back on this one, it's just one big gray blob. So when you add that white in there, you get a little better idea of the bins of the histogram. So it's filling by sex, but it's outlining by the color white. Add on the labels like we've been doing. Maybe choose a palette. Same stuff we did with the bar graph. Now, this is just hard to tell, like, what the difference is between males and females when they're stacked on top of each other like this. Same problem we had with the stacked bar graph we have now here with the histogram. And the way to deal with it with the histogram could be creating a different panel for males and females. And you can do that by using this facet underscore grid and making rows by the sex variable. So this is saying, give me rows, 2 different rows by the variables that I give you, which is the sex variable. So now you've got males histogram on the top, females histogram on the bottom. And you can see that they're labeled male and female. So this is redundant out here. You don't really need it. Let's see, theme minimal, which I think makes it look a lot better here. You can use your favorite theme, take away that legend, and you get this lovely graph. Males and females in 2 different rows. You can see the distribution of age and how it differs between the males and females in these 4 countries. All right. Any questions? We're going to move on to box plots next. So any questions on the histogram? As you can see, it uses a lot of the same options that we've been using. The main difference here is we do histogram up here. You can use this facet grid with bar plots. You can use it with really any kind of plot. And we'll see it again in a minute with a different kind of plot. Okay, moving on. Box plots. So which bin size more appropriate? It depends on what you're trying to show. I tend to leave it on the default, even though it says this up here. I tend to leave it. It looks fine to me. If you want larger or smaller bins, you can set that number to bigger and smaller values. If you set it to too big of bins, then it's hard to see some of the variability in the data. If you set it to too small, it gets all spiky. So I tend to leave it the way it is. Yeah. Okay. Box plots. Box plots are another. So this graph is for a continuous variable of age across a categorical variable of sex. When you have a continuous and a categorical variable, another option is a box plot. It also shows distribution across groups. So we will do one of those. Take that data, pipe it into ggplot. We'll put sex on the x-axis, age on the y-axis. I think you can do it either direction with the box plots. You can try if you want flipping age and sex, the y and the x-axis. Just depends if you want your boxes vertical or horizontal. Add on geom box plot. So there you go. That's your very, very basic, all defaults box plot. You can see the median in the middle there, the interquartile range, the whiskers of the box, which are like 1.5 times the interquartile range above and below. Yeah, so that's your basic. add labels, give it a theme. And so that's, you know, pretty standard box plot. There's a lot more you can do, but this might be good enough if you have a couple of groups that you're trying to compare and you want to see how the median and the spread look one versus the other. Maybe you're doing a t-test. This is a commonly used figure that goes with a t-test. All right, let's get fancy. Global data 2019 clean, so that data set gets piped into ggplot. Sex is on the x-axis, age is on the y-axis. This time I'm doing color, which you remember from the histograms is the outside. It's like the border. If I put fill, it would fill the inside in with color. If I put color, it's going to fill the borders in with the color. So I'm going to color by sex. I'm going to add on. So I'm going to show you some half geoms. Remember at the very, very beginning, we loaded in this package called gghalves. And this allows you to do half of stuff. So half of a box plot, half of a bar graph, half of whatever it is you're trying to look at. So you can see now in this previous bar graph, previous box plot, you had this full box with the line and stuff. When you do a half, you get a half of the box plot. And you can see the color here is the outline color, not the internal color. So right now you see male versus female, how the age is distributed. Males and females are two different colors. If you wanted to, you can add in a half geom that shows the actual data right next to the box plot. So if you add on another half geom, it's going to put the, it's the half points. So point is like a scatter plot. It's going to put the actual data points all right next to the box plot. So you can see on the left side of each of these groups, the box plot kind of summarizing the spread and central tendency. And on the right side for each group, the actual data points and how the distribution looks. The alpha equals 0.4 in here is making the color transparency a little higher so that you can see the individual dots a little more clearly. If you don't put that in there, the dots will just be the full-on color and they kind of become a big blob if you have too many of them in one space. So you can take that alpha equals 0.4 out and run the code again and see what it looks like if you like. That's often the best way to kind of get this into your head. Let's see, where are we? We're on chunk 24, if you haven't gotten to that already. And let's do a couple more things here. Add on labels, add on a theme, take out that legend. So now you get this lovely plot that's showing the spread and central tendency for age for males and females, and the actual data points sitting right next to it. So you can see that the median age for males is lower than the median age for females. The spread of age is a little bit wider for females than males across these 4 countries. Yeah, so for more than 2 variables. So you could use the facets again for that if you put another variable as the facet variable. But we'll go ahead and do grouped box plots now and see how that goes. So grouped box plot, I think, is maybe what you're asking about. So we'll take the data, pipe it into ggplot. So now on the y-axis, we're going to have that ladder now variable, which is a continuous variable asking on a scale of 0 to 10, how good is your life, where 10 is the best. X-axis is country, so you've got Israel, Lebanon, Tunisia, and Ukraine on the x-axis. The data are going to be colored by sex, so that's again going to color the border, not the internal part of the whatever it is we choose. We'll add on geom box plots. So you can see in Israel, people like, so this ladder now is how good is your life? It looks like Israel's got, people are saying their lives a little better than the other other three countries, and the other three countries are remarkably similar, at least for the median, which looks like it's at 5 in all of them. So go ahead and add on the labels, go ahead and add on the theme. Oops. And that's all I did here. You could do some of the other stuff we did if you'd like. You could use half geoms. You could do all kinds of things. You have to be careful when you start to get too many variables in a graph, that you're not making it too hard for people to kind of comprehend what you're saying. And so leaving things a little simpler when you get more information in here might be a better way to go. But I'll show you some options for continuing to make it fancy if you'd like. So that's going to be, I think, it for box plots. You could use facets if you wanted to have each of these countries separate in a separate facet instead of all next to each other like this. You could use that facet _ grid that we looked at before. Yeah, lots of things you could do. Any final questions on the box plot? Okay, so that code is chunk 25. We're going to move on now to a rain cloud plot, which is kind of cool. And this is kind of a new kind of visualization that people are starting to use. And this is another thing to use when you have a continuous variable like age, or like that quality of life ladder variable, and then a categorical variable or two that you want to look at the distribution across, look at the distribution of age across sex and country satisfaction, or whatever it is you're doing. So take the data, pipe it into ggplot. So here we've got sex on the x-axis, age on the y-axis, color by sex, so that's the border that's going to be colored by sex, and the fill and the inside is going to be colored by sex. You can do that on any of these, but if you do it on a box plot, it's going to make it so you cannot see that median, because the whole thing will be whatever color it is you chose. So I would be careful using color and fill together. It just depends on what kind of graph. You always have to play around to get a good sense of how that works. Add on a geom half violin. So the violin plot, and somebody's leaving, so have a great evening. And let me know if you have any questions. I'm available on Twitter and email. Okay, so we're going to do half a violin, which is a little bit like a histogram. It's a density plot, basically. It's like a histogram, and then it shows the shape of the data, but it's all smoothed out, so you don't have those little bins. So that's the half violin, and I want that half violin on the right-hand side, so I put side equals R for right-hand side. And then I'm going to add on my points, so my data points on the left-hand side. So I put side equals left, and alpha equals 3 to make them a little more transparent, 0.3, so that you can kind of see all the points and they're not like super dark orange or blue. Oops. Wow, I showed you the final without going through all the steps, but then you can add on the labels. Then you can choose a palette. So you're going to have to choose a palette twice now. You've got color and fill. Both of those will need a palette. So this is Scale Color Brewer. So this is going to do the palette for the outlines around stuff. And then you're going to add Scale Fill Brewer, which is going to do a palette for the insides, whatever fills in the different kinds of graphs that you're looking at. So I chose the same palette for both, which is typically what you want to do. You can try one palette for one and another palette for the other. It'll look more like this, where you have one color on the outside and a different one on the inside. So I recommend both being the same. And then you can choose your theme. Goodness, my mouse is very touchy. Then you can choose your theme, and then you can flip the coordinates. So go from vertical to horizontal. And so now you get to see why it's called a rain cloud plot, because the violin that's on the top, that density plot, looks like it's a cloud and it's raining all the data points down. But this is a very nice way to look at the distribution of continuous variables across groups. So you can see that, there's a little different shape to the distribution of age among females across these 40 countries compared to males. And it's super clear with this kind of a plot. And not only do you see the summary with that cloud, but you also see every single data point underneath it. Get rid of that legend, you don't need it. You already know that males are green and females are that rust color. So that's gone. Let's see, I don't even know what happened there. There we go, okay. Grouped rain cloud plot. So maybe you've got, you want males and females, distribution of age across the 4 countries. Harad, recommendations on box plot versus violin plot. I would tend to use box plot when I'm comparing a lot of groups. I don't know, I like them both. Violin plot, the one thing that people criticize the violin plot for is that if there is a place in the data where there are no values, so like maybe nobody in your data set was between 55 and 60 years old, the violin plot will not show you that. I guess neither will the box plot. So in that kind of a case, you'd want to use a histogram over a violin plot. Other than that, I don't think there's a clear place. The box plot shows you the median and the interquartile range. So if it's useful to have that information for whatever you're working on, I would go with the box plot. If you're more interested in the full distribution and how it looks, I would go with the violin plot. It depends on the story you're trying to tell. Okay. So grouped rain cloud plots. So what if we wanted to know, is there a difference in the distribution of age for males and females? And is that different in Tunisia than it is in Ukraine, and so on and so forth? So you can do that using all the tools that we've used so far. Pipe the data into ggplot. You can, my code's cut off a little bit here, but you can see this in chunk 27. You're putting the ladder now, so the happy life thing on the y-axis, the country on the x-axis, the fill by sex, and color by sex as well. Using the half violin on the right-hand side, now you see, like, maybe you were trying to do too much. So this is a lot kind of to look at visually, and if we add the points, it's even more. So this is, this is maybe a case where the complexity of the type of graph that I selected is a little much for communicating. But we can kind of clean it up a little bit and make it a little better. We'll take the labels, put them on theme minimal, flip the coordinates. And now it looks a little better now because you can kind of see the shape, and you can see that, like, Israel, they have a little happier life than the other countries. They're in Tunisia, it looks like there's a pretty clear difference between the shape of the curve for the men and the males and the females. So you can see, you can get a little bit of the difference here. You can fill it with the better colors if you'd like. And so you could do a graph like that, and that would give you some nice, a nice visual for some research question you might have. But a better way to go might be to add on those facets that we used before. So we're going to go all through the same steps, but we can put the facets here. This time, instead of facet grid, I use facet wrap so that I could have rows and columns. And I want the facets to be by country. So now I'm going to look at the ladder, the life ladder, happiness thing, fill it by sex, color it by sex, and then I'm going to have a different facet for each country. So then I can add on my half violin. And already it's kind of easier to see the shapes of these because they're a little bigger in each of the 4 boxes than they were when they were so long and stretched out. Add the data points, add the labels, add the theme, flip the coordinates, change my colors. So now you get Israel, Lebanon, Tunisia, and Ukraine. And you can see within each country the difference in worst to best life. Yeah, snow and rain. It could be a snow plot. That's true. The difference between best and worst life for males and females in each of the 4 countries. So you see a really big difference in the shape in Tunisia for life for men, males and females. The shapes in the other 3 countries seem pretty similar, although maybe Ukraine females look like maybe they have a little higher peaks in the middle there, and fewer people on the worst side of life. So anyhow, that's one way to use like all the different features we've been working on today. So that is all the material I have, and I just we have about 15 minutes, and I'm happy to go through anything again, answer questions. I have some things that if you wanted to, you could work on and just try stuff out yourself. And I'm happy to help you create any of these graphs. So that's it. That's what I have. At the very last slide, and I'll put these slides up on that GitHub, has my email and Twitter handle, and I can copy this and put it in the chat as well. Cool.
Thank you so much. It was very great event. We've learned lots of things from you, and it's really our pleasure to have you. And if anybody have any questions, please ask from our professor.
Yes, so Vishnu had a couple of questions on the R Markdown file. Let me go back over to my R Markdown. So I usually start with an R Markdown file. I don't necessarily create one from a code file, but I could. Thanks everyone. If you have to leave, I appreciate it. I hope that I hear from some of you in email and Twitter. And I'll put the slides up on the GitHub soon. All right. So the 2 questions I think we have are how to create R Markdown from code, and then also how to get your file, your plots in a separate file. And both those are great questions. Creating an R Markdown from code. If you have a code file and you just want to turn it into an R Markdown file, you can open it and save it with this RMD extension right here. And then anything you want to be perceived by R as code, you'll have to surround it with this at the top and this at the bottom. So you'll have to go through your code and add backticks and the little R and the curly braces at the top and plain old backticks at the bottom. Anything that's outside a code chunk will not be perceived by R as code if you're in an RMD file. I would just start with a blank RMD file. So you can do that by going File to New File, and it's the 3rd thing down in the new file called R Markdown. It'll bring up this right here. You can give it some kind of a title, New R Markdown file. Whoops. I would leave all the defaults just the way they are and then hit OK. And it'll give you a little R Markdown file that you can now work on. And these are all instructions. When you open this up, I would just delete everything after the second. You want to leave this stuff because it needs that. But you can delete everything after this 3 dashes and then just start, writing in here. So this is some notes for myself or a title. And then if you want a code chunk, you can come up here and choose R and it'll make a code chunk for you. And now you can write some code in here. Or whatever you're trying to do. Then you can write some more text out here, blah, blah, blah. You see how it goes. Okay, so that's how you create an R Markdown file. I'll go back to our other file. How do you get the graphs out of here into your document? So let's go back and find, maybe I want this graph to go into a report or something like that. There's a couple ways I could do it. Once I have my R code exactly the way I want it, I can copy this. I just hit Control-C and take it to the console and paste it there and hit Enter. And it'll put it over here in plots where you can then export it to anything you want. Save as some kind of image, PDF, copy it to your clipboard and paste it in your Word document, however you want to do that. If you want it to always appear over here as you're working in an R Markdown file, you can set it up so that all the output from everything you do comes out in your console and in your plots instead of in line with your code. And the way to do that is to go up to this little settings gear, hit the arrow next to it, and change this to, it should be on the default, should be chunk output in line. Change it to chunk output in console. And then everything you run will show your output where you're used to seeing it if you're used to using just plain old R files. Cool. Does that answer your questions, Vishnu? Okay. Yeah, fantastic. All right, somebody's got their hand up. I'm going to say your name wrong. I'm sure Dariush. Is that right?
Hi, Jenine. Thank you so much for such an informative presentation tutorial. I had just quick question about the saving and the output of a ggplot. Is it possible to directly pipe it into the ggsave and save it in your panel or directory? Because I normally would try to do that, but it wasn't possible for me until you put all the commands for producing or generating a plot into a double parenthesis and then pipe it into the ggsave. Otherwise, you have to name it and just say put the name into the ggsave or use last plot attribute.
So is this what you did?
Just one parenthesis is enough. I guess I just
okay.
Right.
And you
normally pipe it directly into the ggsave.
Okay, I haven't done
that. That was a trick. I don't know if it is possible to do that, something like that.
Yeah, I would have to, I'm sure you're right that there's something like that we could do. It's not something I've done. I mean, you could do. And
you I guess you need to specify the name and the size somehow. Right, right. This is a normal.
And then just do ggsave. File name equals, whatever I wanted to call it, plot name.png or something. Yeah, I don't use ggsave very often, so I don't.
I guess the name should be on quotation, double quotation.
Okay.
And then you need to specify the name, which is plot name.
plot name.
or using the attribute which is last plot.
Okay, let's, I'm gonna go switch over to my files and run this and see what happens.
I don't think that plot name should be in double quotation in this.
This one? Okay.
Right, because no need. Right.
There it is. Saved it. Yeah, that's
Right.
great. So that's another way, Vishnu, that I didn't know before. So thank you for sharing that.
Oh, thank you.
I'll copy all this and put it in the chat in case anybody else wants it.